Okay, the basic premise for this section of the chapter is just understanding trigonometric functions, which are just what sine, cosine, tangent, cosecant, secant, and cotangent are. That's all it is. So if you have an angle like theta over here, which is an acute angle, so basically the angles of a right triangle that are not the right angle, you find the trigonometric functions by using the ratios of sine, cosine, etc. So for example, sine is opposite over hypotenuse, opposite is b, hypotenuse is c, sine of theta is b over c. In order to find those ratios and have them have actual numbers instead of b and c, you have to have the values of sides. So you have to know what number or length a, b, and c are. Let's say we know that a is 3, c is 5, and we don't know what b is. So all we do here is use the Pythagorean theorem. Over here is how you solve that. You have to square 3, b, and 5, and ultimately b squared is 16, and b is 4. Now that you know all the sides of the triangle, when you do sine of theta, you have opposite over hypotenuse, which in this case is 4 over 5, and that's a trigonometric function, which you can do for all of the others also. Let's say you have to find an area of the triangle and you only know one side. The hypotenuse is 4. You can also solve this using trigonometric functions. In order to find a, you're going to want to use cosine because cosine involves the adjacent, and a is adjacent to theta. So cosine of theta is a over 4. Multiply both sides by 4, the value of a. For b, you're going to want to use sine because b is opposite, and you get sine of theta is b over 4. Multiply both sides, this one by 4 also. Now you just use the formula for finding the area of a triangle, which is 1/2 base times height, or 1/2 a times b. You get 1/2 4 sine theta times 4 cosine theta, which is 8 sine theta cosine theta. For this next part, all you need to know is which cofunctions are pairs with each other. So it's sine and cosine, secant and cosecant, and tangent and cotangent. As long as they're complementary, their values are the same. Here, a and b have to be complementary because the third angle is 90 degrees, which means their cofunctions are equal. Here's why. We know that sine of b is 3 over 5 because 3 is opposite and 5 is the hypotenuse. The cofunction pair of sine is cosine, so we can do cosine of a. Cosine of a is also 3 over 5 because 3 is adjacent and 5 is still the hypotenuse. Clearly, those cofunctions are equal. Remember, this is true for any complementary angles. 30 and 60 are complementary because they add up to 90 degrees, and sine and cosine are cofunctions of each other. Sine of 30 is 1/2, and cosine of 60 is 1/2. So those cofunctions are equal. Here's an example problem. Sine of 62 is equal to cosine of whatever angle is complementary to 62, which is the same as 90 minus 62, which is 28. So sine of 62 is equal to cosine of 28 because they are complementary angles. You can also do this with radians. Here's a right triangle with some missing lengths and angles. The angles are easy because we already have 40 and it's a right triangle, so this is 90. Remember that all right triangles' angles add up to 180 degrees, so 180 minus 90 minus 40 is 50 degrees. So now you want to find C and A. In order to find A, you want to find the opposite of 40. So you do tan. Tan 40 equals A over 2. And if you multiply both sides by 2, you get 2 tan 40, which is roughly 1.68 cosine 40, 2 over C. And using algebra, C equals 2 over cosine 40, which is roughly about 2.61. Now sometimes you'll have something where you just see tan theta equals 3/2 and you have to find the angle. To do that, you just enter in your calculator the inverse of tan, parentheses, 3/2, and it will give you the answer in degrees. In this case, that answer is about 56.3.
If you're looking up at an object like a cat, this angle right here is called the angle of elevation. If you're looking down at an object, the angle is called the angle of depression. Now, weirdly, if you have to find the height of a cloud, you use a device called a ceilometer with a light projector and a light detector. And if you are asked to find the direction of bearing, you're just looking for the angle of the point towards the y-axis, like all of these angles.